Hi, welcome to the channel. I hope you all safe and doing well. In last two sessions, we discussed about bubble and insertion sorting. In this session, we look into the selection sort algorithm. Selection sort is a simple sorting technique with order of n square complexity. It is an in-place comparison based algorithm. That means the sorting algorithm will not take extra space to sort the given data. This is good for only small data sets. It sorts the given data by repeatedly finding the minimum element from unsorted section and putting those into the sorted section. Now we will see how the selection sort algorithm is implemented. This algorithm divides the given data into two sections as sorted and unsorted. Initially, the sorted section is empty. Now take the first element from unsorted section and start finding the minimum element among the unsorted section. Once you get the minimum element, then swap with first element of the unsorted section. Repeat the same steps until the given data is sorted. Let's take this as input data. So we have to sort this data. Now divide this data into two sections as sorted and unsorted. Initially, sorted section is empty and unsorted section is the entire given data. To sort the given data, take this element and call it as key element. Okay. So with the help of this key element, start finding the minimum element among the unsorted elements. See, the key element is 17 and we have to compare with all other elements. So the next element is 8. Hence, the 8 is less than key element. So update the key as 8. And continue to find is there any other small element other than 8 till the index reaches the end of this data. So we got another small element, that is 1, and now update this key as 1. Continue the process of finding minimum element till the index reaches the end of this data set. So there is no other minimum element, so now we have to swap this 1 with leftmost element of this section. So after swapping, the given data looks like this, and I call this as pass 1. Now again we need to divide this into two sections. Let's continue to find the minimum element from this section. So we have to take 8 as key. Then start comparing with the other elements. Include 7 as a small element. So we will update the key as 7 and look for small element other than 7. Yes, we have small element 2. Then update the key as 2. Now swap this 2 and 8. Okay, again divided into two sections and update the key as 17. So start finding the minimum element. So we have 7 as minimum element and updated the key as 7. And look, is there any other small element? No, there is no small element other than this. Hence the 7 is the smallest element. So we have to swap 7 with 17. Okay, now again we have splitted this into two sections. Now take 10 as key element and start finding the minimum element. So 8 is the minimum element. Then we updated the key as 8. So we have to swap 8 and 10. So after swapping, we divided into two sections. Now we left only two elements, 17 and 10. So take 17 as key element and start finding the minimum element. So the minimum element is 10. Okay. So see, the only one element is left. Okay. So only one element is left means obviously this is sorted. This is how the selection sort implemented. And one question, why this named as selection sorting? Any guesses? Yes, this algorithm is implemented by selecting the smallest element or largest elements from the unsorted section and put into the sorted section. Hence this name as selection sorting. Yeah, hope you all got this. Now jump into the coding. Let's define the given data. Let data equal to 9, 1, 10, 17, 2 and 6. We'll define one function sort, and as I said, we need two loops. Okay, I is equal to 0, I is less than data dot length minus 1 I plus plus. So we have to take one element to find the minimum value, right? So this is the first element, so we have to take this element. We will call this as let key equal to I. Why I means we have to take the first element, that's why I taken as I. Okay, so we need another one loop, that's for comparison. Let j is equal to I plus 1. Why I plus 1? See, this we have taken as first element, so we have to start comparing from here, right? So that's why I have taken j is equal to I plus 1. J is less than data dot length and j plus plus. So we have to add one condition to comparison. Okay, if data of j is less than data of key. Okay, if it is true, then we have to update the key value, key of j. Okay, so after this loop I will add another one condition. If key is not equal to I, then we have to swap. Let temp equal to data of key, data of key is equal to data of I, then data of I is equal to temp. So okay, so I will print the process here, console.log and this is the data. Okay, and I will print the output console.log so we'll call the method. Yeah, this is the output. We got the output, expected output. Okay, let's trace out this one. Okay, I will take one case. Okay, see, as I said, we have to take the first element from the unsorted section and compare with all the other elements to find the minimum value. If we get the minimum value, we have to swap with the first element. Okay, see, so this I have taken as a first element as key. Okay, and with this key we have to compare with all other elements. Okay, that I am doing in this case, in this if condition. Okay, I am comparing this 9 with j. The initially j means I plus 1. I plus 1 means 1. The value is 1. Okay, so data of j means 1 and data of key is 9. So 1 is less than 9. Yes, that's true. So now the key is updated is as 1. Okay, j means 1. Okay, so this is updated. Okay, now again j will increment by 1 and j will become as 2. Okay, so j of 2 means 10. J of 2 means 10, and what's the key value? Key value is 1. Okay, data of 1 means 1. Okay, so 10 is less than 1? No. Okay, so this condition will be false. This condition will fail. Okay, so now again j will increment by 1 and that time j will become 3. Okay, so see, data of j means 17. Okay, so the key is data of key means 1. So 1 is 1. Okay, so 17 is less than 1, no, again this condition will fail. Okay, now again j will increment, and that time j will become 4. Okay, and that time 2. Okay, 2 is less than 1, no, again this condition is failed. Okay, now again j will increment by 1, so that time j will become 5. Okay, j of data of j means 6. Okay, 6 is less than 1, no, again this condition will false. Okay, then it will come to this controller. Okay, see, key, what is the key value? Key is 1, and what's the value of I is 0. Okay, so 1 is not equal to 0. Okay, yeah, this condition is true. Then again we will swap here. Okay, after that I am printing the passes and the output. Okay, yeah, let's stress out yourself by taking the some other cases. Okay, yeah, this is all about the selection sorting. Yeah, now we'll see the examples in real time how we will use the selection sorting. Let's take this as example. Okay, so we have few files. Okay, we have to sort these files with the file size. Okay, let's take this one. See, we have 15 MB for this file size, and we have to find the smallest file size. I mean for smallest file. Okay, the smallest file is 1 MB. Okay, so we have to swap this one, and we have to place other things as it is. Okay, and this become as a first pass. Okay, okay, now so now this is sorted and this is unsorted. Okay, so we have to take the 10 MB file. Okay, then we will again find the smallest file. The smallest file is 2 MB. Then we have to swap with 10 MB file. Then remaining things will keep as it is. Okay, now take this 11 MB file. Okay, so see, is there any smallest file? Yes, we have 10, but we have 7 also. Okay, so we'll take 7. Then we'll do swapping, and remaining things will keep as it is. Okay, now take this 11 MB, and we have to start find the small file. Small file is 10. Then we have to swap. Okay, now we have 15 and we have 11. Okay, obviously 11 is the small, so we have to swap. Okay, so now this is how we will sort the files. Okay, I quickly summarize what we discussed in this session. We discussed about what is selection sort and why this is named as selection sort, and what's the algorithm of this selection sort, and we implemented this algorithm with code. Yeah, well, this is all about today's session. We'll catch up in next session. Till then, bye bye. Thank you.